Ladies and gentlemen, welcome to the third Auto-DAN Roadshow. My name is Simone Buffa, and I'm thematic area leader in R2M Solution. Today I will moderate this event. For us, it's really important to disseminate our results. And apart from Auto-DAN, we will have also a session dedicated to the SATO project. So let's move forward looking at our agenda today. So I will introduce briefly Beatriz Fraga from R2M, from IS. She is the coordinator of the Auto-DAN project. And then we will have a session focusing on two pilots located in Italy. And then we will have a pinch summary session where we are going to present you some cutting-edge technologies that are we developing in this nice project. At the end of this session, we'll make also a short survey, because for us it will be really interesting to see your point of view on such aspects, since you are mainly going to treat both somehow advanced control platform as well as what is called augmented intelligence. So welcome again, and I will leave the floor to you, Beatriz, for your introduction.
Probably for remote people. A rule, it's a conference rule. All right, all right. So thank you, Simone, for the introduction. Thank you, everyone, for being here. So it's the last session of the day, so hopefully it's not too boring for you guys. So my name is Beatriz Fraga Di Cal. I work for IS, and apparently I don't talk loud enough. Anyway, I am the project coordinator for Auto-DAN. Auto-DAN stands for this long sentence, that is deploying augmented intelligence solutions in European buildings using data analytics, interoperable software and hardware architecture, and a novel self-energy assessment methodology. It's quite a long sentence, so I'm going to try to explain that in a more simple way. So first was the problem that we are trying to solve with Auto-DAN and the project relevance behind it. So all projects start with a problem, and this is not an exception. So as we all know, we have an energy crisis within Europe. The cost is increasing. The primary energy sources are not particularly sustainable, sometimes come from far away. However, the residential market has been slow to adopt to new technologies, and there is a lack of information for them on how to best reduce the energy consumption. They don't really know what they have to do. And that's why we built this team. We have built a consortium of around 12 partners. We have 4 partners in Ireland, that is IS, TU Dublin, mSemicon, Oculen, and then in Spain we have Universidad de Burgos, Cardiff, and in Italy we have RINA, Flerbit, R2M, Delta, Ecopolis, Schneider, and last but not the least, we have Arçelik in Turkey. Some of them are here today, and they will present technology, so you will meet them in the upcoming sessions. And here is the basic goal of Auto-DAN. So what do we want to achieve as a team? So the basic intention and the basic goal of Auto-DAN, as previously introduced in the problem, is to provide the home residents with this knowledge and information, so we can give them some feedback on what to do, on what not to do, so they can understand the impact that their behavior can have in the energy performance of the buildings. How we'll do it? Well, we will collect, we are collecting already. We will collect data and do a detailed analysis of this data, so then we can actually provide these recommendations, feedback in a simple way, because this is designed for non-technical users. Those are the 5 key specific project objectives of Auto-DAN. So the first one is to create this hardware. We need to create the smart hardware infrastructure. So all the buildings have like BMS, IoT sensors that we also describe later. We have to develop also interoperable software. That means like we have to make all these smart things and softwares and automatations, they need to talk to each other, and we all know that that's not as easy as it looks generally. For, at the end, deliver, and that's the third objective, an augmented intelligence solution. Last, but not least again, is deliver the live energy assessment method and accelerate investment in sustainable energy. And here's just like a small, well, it's like an overview of the brain of Auto-DAN, like a basic one. And that's basically the platform. So on the left-hand side, we have the hardware infrastructure. That's where all the smart appliances, BMS, sensors, all of them are connected to Society. Society is the data management platform. It's where all these devices are connected and where the data is stored. Then the data is connected to iScan. iScan is a data analysis platform. That's where we organize, centralize, and improve the in-use operations. That's where we try to improve the in-use. That's the data part. Then we have, in the center, you see the interoperable software and the self-energy assessment. Both of them use that data and those platforms as a foundation to work. In particular, the software architecture has 2 main features. One is the digital twin, and the other one is the digital occupancy model. Both of them try to provide, the aim at to provide insights to the user on how to make best use of the energy, but at 2 different levels. One is at building level, the digital twin, and the other one is at appliances level. And here is a list of, I'm not going to jump to the demonstration sites. We have 6 pilots, and in the next sessions, we're going to talk in particular about the 2 Italian ones. So I'm just going to give like a brief description of all of them. So we have a mix of residential and small business, which makes Auto-DAN quite interesting because the interest of our users changed. So that was a challenge. So this is Oculen. This is a A-rated homes in Ireland. Then we have Palazzo Terrani in Italy. That's a theater from, it's a heritage building in Lisbon that will be discussed later. We have University of Burgos. This is a social housing in Burgos. Then we have Delta Ecopolis, that is also like an apartments block from the 70s in Italy, Milan. And then another pilot in Burgos is the Residencia Camino de Santiago. This is a student accommodation. So as you can see, and the last one that we'll talk about later is the business park. It's a business park in Dublin called Greenock. We have the chance to talk to the pilot responsible later on. So as you can see, it's a wide variety of pilots. Well, and that's me. That's just put here how to keep in touch. We have our LinkedIn page, Twitter, our newsletter that comes regularly, and obviously our website. So I'm not going to reveal more because I think the key exploitable results is what's going to be more interesting. And just to give you a brief overview.
Thanks, Beatriz. So let's move forward quickly. So now we will present shortly the insight on 2 pilots that are progressing in this project. I will briefly describe you this theater that is protected by the heritage protection law in Italy, and then we have another pilot. This is a residential multifamily house in Milan that will be presented by Elena Comotti, that is an energy manager of LIU. Good. Let's get starting from this pilot. So for the others that just joined, I'm Simone Buffa, and I'm the project manager in Artsam for the Auto-DAN project, and I'm responsible for the implementation of this pilot. I will give you a brief overview on the buildings, the HVAC system, and I will present you briefly the intervention that we are going to make and all the issues that we had and troubles for the implementation, because it's nice to see some results, but it's also really challenging to implement the infrastructure. And then I will just describe the next step, since we have not implemented the solution yet. So just giving you a feeling on the numbers, the 35% of the EU building stock is already over 50 years old. So this means that several of those buildings can be already classified as a historic building, and some of them are probably also protected by the some national laws for heritage protection. And this is the picture of Palazzo Terragni in Lisbon, so just in the northern area of Milan. And in the past, actually, this building is an example of the Italian rationalist architecture, since this was designed during the fascist era. Actually, it was the headquarters of the fascist party in Lisbon. You can see somehow the first drawings of this building, and actually from that tower, Mussolini should speak to the crowd, to the people there. And then, yeah, that is this tower that is also a memorial for the soldiers. And now, from 1968, this building is owned totally by the municipality, and it's begun now the cultural center of the town. So it's the main theater they have, with some exhibition hall and meeting rooms. And it has been already renovated on the external side, but yeah, concerning the HVAC system and monitoring control platform, the situation is really poor. So what we are going to implement there is not too much space if you don't work a lot on the HVAC system. But through the Auto-DAN solution and the technologies that the partners are providing this project, the idea is to mainly work on some electric boilers, so that they can be turned off, for instance, during the period when this building is not occupied, because there are long periods when this building is not occupied. But in the long term, we may expect that those boilers can provide a small amount of power flexibility, for instance, when it would be possible. In this building, actually, there are a lot of restrictions. You cannot insulate the walls. You cannot install PV panels on the roof. So actually, working with a building management system is one of the main, of the few energy renovation measures where you can work with. The HVAC system looks quite complicated from this diagram. Actually, it isn't. We have just a gas boiler on the bottom left side, and air-to-water chiller that provide cooling water on the bottom right side. And those two somehow main machine supply hot or cold water directly to fan coils, but also to a high-end unit that manage all the air, somehow temperature and humidity condition, mainly for the theater. And as you can see from the few pictures here, the HVAC system is quite dated. So probably in the future there will be the need of huge investments on that. But for now, in this project and with the budget of this project, we are going only to work on managing the monitoring and control infrastructure, improving it, and using the same somehow, the same machine. So here there are some other pictures where we are going actually to install and do other modification. We are actually going to install new meters in the existing electric cabinets, but on the other hand, we are also going to install some air and humidity sensors, as well as CO2 sensors and occupancy sensors, to have the full possible information somehow to optimize the control of the building. So here there is just a diagram with the different intervention. We are going to use mainly the Schneider infrastructure that is a partner of the project, and we supply somehow all the hardware and the local somehow software solution. And as you can see from this chart, we are going to have a main controller that communicate with the somehow with the main machine and the other controllers using mainly an Ethernet cable. And then actually we have all the monitoring infrastructure for the internal air quality that will be made through a Wi-Fi Zigbee. And why this is important? Because for those sensors, actually we avoid to install cables. We avoid to somehow work on the walls, working on the somehow on the roof, and this way we avoid somehow important intervention on the buildings inside that are even there not allowed. So and just to simplify it a bit, what we are able to do actually is to manage the heaters, so the fan coils only for each single floor, because at the beginning there was the idea to control each single fan coil with our control platform, but this required important intervention because you need to cable each fan coil by with a single line, and that will require some important intervention that somehow are not possible. And then from this local somehow infrastructure that will be equipped with a set of smart plugs for managing the electric boilers that I mentioned before, we are going to exchange the data through MQTT protocols with the SenseIoT platform that is the main somehow data collector somehow from all our pilots. It was a really huge effort in checking an existing system, so it's, I would say, really easier when you start from a new building, but when you start from something that is old and existing with few information available, it takes a lot of time, a lot of somehow site visit, check and double check of the existing material. And then from that, we were able to reconstruct somehow the new IT infrastructure, doing also the modification page by page on what will be substituted from the existing somehow electrical and control system. There was also an important work with the municipality, because again, this is a public building, and we actually doing this intervention on a public building. This is usually really difficult to manage in new projects, but it's difficult even in reality. For us, it took a bit of time, also with a lawyer for a consultancy, but we were able to manage it. So now we have an agreement with the municipality. We have just to finalize some technical verification. But what was also important was to put those collaborators of the municipality in touch, because usually the different departments don't talk with each other. So it was important also to get them aware of this project, because the final idea is that through the Auto-DAN platform, the building control is totally somehow automatized according to a calendar that they have, where actually, for instance, when there is a particular event, they can book a room, an area, and automatically the Auto-DAN solution somehow works to meet somehow the comfort condition during that time slot. Concerning the next step, so we completed the design, we completed the agreement, we also somehow individuate the installers, so now we are ready to start the installation work soon, and then together with this we are going to finalize together with the other partners somehow the monitoring platform and the dashboard, that in this case will be also a bit simplified, because the idea is also to share the main information to the general public. So children, residents that are going to access the building, they will have an overview of the consumption and improvements that have been achieved. And that's all from my side. Thank you. Let's move forward with Elena Comotti, Energy Manager at Loom, that will present another pilot located in Milan. The floor is yours.
Thank you, Simone. Okay. Loom and Delta Ecopolis is the same. Loom is one of Italy's largest housing cooperative. Is born in 2024 through the merge of Delta Ecopolis and two other cooperatives in Milan area, Ferruccio De Gradi e Abitanti Settimo. The three cooperatives has built the first building in early years of 20th century. Loom have contributed to Milan's urban development and meet the housing need of more than 10,000 families. Over the course of century of history, they have built up a significant housing stock, which today include more than 2,800 individual ownership located in different areas in the city. Our number, we have 110 years, 7 territorial offices, 12,000 members, 2,800 lodging, and 241 million of shareholder equity. We spent over 37 million on extraordinary maintenance and energy upgrade in our pilot is a residential complex located in Milan in southeastern area. Was built between 1968 and 1970, consisting of 3 buildings, 2 in line and 1 tower, totaling 135 dwellings and 2 offices. The complex has a single thermal power plant located in Media 10, and a tunnel under the roadways allows service to be distributed to the other building. Between 2013 and 2017, the 3 buildings were completely renovated. Facade resurfacing with EPS insulation and finishing with 2 centimeters of paramano to resume the original facade. Complete replacement of all exterior and interior light with LED elements, and complete renovation on the thermal power plant, installation of thermostatic valve and metering system on the radiator. Sorry. Post-renovation, the consumption dropped by 25%. Now, for saving is up to behavior of a resident. In Auto-DAN, we monitoring the thermal system with accounting unit, environmental sensor for temperature and humidity, thermostatic valve or smart valve, and gateway IoT. All the data is collected to the Brunata platform and transmitted from SenseIoT in iScan. Also, we have electrical monitoring of individual housing and office is also through the use of Schneider power tag. The power tag is an energy sensor designed specifically for energy management, load monitoring, and power availability application. Data are transmitted to SenseIoT. The data collected in this way are sent to the platform and returned to the tenants in the form of information they can see on their tablet. The initial meeting has been made with the tenants to present the platform, and we are waiting to hand them the final version.
Thanks, Elena. So let's move forward quickly. Now we will, this was just somehow a taste of the main solution that we are going to apply. But now there are three project partners that are going to present both some software solution that we are applying in Auto-DAN, as well as some new metering system that have been already started in some pilots. So I welcome here Beatriz again. Then we have also Ciarán and Arianna from RINA. Beatriz, the floor is yours.
Thank you. Sorry. So here I am again. This time I'm going to speak. I've chosen the augmented intelligence dashboards and digital twin models as one of the key exploitable results of Auto-DAN. So I'll start with the user-centered approach behind. That was a critical step. Then I will go through the data collection and interoperability. Next, I will focus on the augmented intelligence part. And finally, before conclusions, I'll highlight the digital twin functionalities. So the user-centric design in the UX process. That's the end user experience. That's the first step before we build any dashboard or any software. And the reason is because we want to know what do we want to solve, what's exactly we're trying to solve, what's the use case behind that, and the best person to respond is the user. So that's why our UX team has followed this problem-solving technique that consists in 4 steps: strategic alignment, research, analysis, design, and test. I'll go through all of them very briefly. So the first one, the phase one, is the strategic alignment. Here, I think there are two main outcomes: the definition of the problem statement, and therefore the definition of the goal. So what's the pain of the user? What do they want to overcome, right? So here was the lack of clarity on how the behavior impacting the energy performance. They didn't know what to do to make things better. So that aligns with the goal definition, that is created an augmented intelligence dashboard system for non-technical building users. That's mainly it. And that comes from long workshops among a lot of stakeholders with different backgrounds. And it is challenging to put so many people with different backgrounds and interests in the same room to understand what we want to do. I'm sure all of you has gone through this process. And yeah, it is critical. It is critical to deliver what we actually want to deliver. Anyway, in the phase 2 and 3 is the research and analysis. Here, again, we have workshops among all the stakeholders, and we create the personas. We create the profile of users that are involved in the solution that we want to provide. And for example, a business owner will be more interested in the investment, right? However, the homeowner is going to be more interested in the energy bills. So same solution, different people, different objectives, and that's a bigger challenge. So, and finally, phase 4, we design and test. Here, again, more workshops where we test prototypes, we get the key user interviews, we design workshop, each team member provides like a prototype and the stakeholders vote. So we finally get the prototype that we want to deliver. Next one, that's the UX part. Now I'm going to focus on the data collection and interoperability. The format has changed. Anyway, and thus the interoperability in Auto-DAN comes mainly from Society and ISCAN. So Society is the platform that Elena and Simone were talking before, is where all the devices are connected. But then we have to send this data to the data analysis platform that is ISCAN. And that is where we're going to analyze the data, create recommendations, and find the intelligence behind that. We've done that through an API that Flairbit developed for us. And at the end, that's what you see on the top. At the bottom on the right is all the channels in ISCAN connected. So everything that is in Society now, it should be in ISCAN. And that's what we are working at the moment at project level. And that's a simple display of what you can see in ISCAN as a time series data. So that shows the electricity consumption at early level in one of the apartments. That's the main chart, and the chart at the bottom, it just shows the data points that we have and the quality behind it. So green means we have a lot of data points. In the red one, we don't have so many data points. So we have an alarm system also set up, and in this case, like we just had to go on site and sort it out. Like some of the users have probably switched it off. And that's another challenge in this type of projects, that sometimes you install things, but you're not in the building, so I need to go there, check how things are going. Third part, the augmented intelligence dashboards. So at the end of the day, these dashboards are for non-technical users, and we need to show them the operational insights to those non-technical users. And this is how it looks at the moment. So on the user can see like the electricity consumption, CO2, and electricity cost, tariffs that they have provided with some saving suggestions. If you click in one of the consumption, you can see like a breakdown at hourly level. You can also choose weekly or monthly. and also have some saving tips that at the moment are static. Then we also have at appliance level display. That is more, you need to go to the room, and it's more about the sensors that we install. So here we have the whole temperature, humidity, temperature and humidity in both those rooms. You can click on and also see the pattern of that sensor. And in the case of the dishwasher, is the same. We can see the consumption of those appliances, and based on those patterns, like, the idea is to recommend the user when best is to use them. Last, the building digital twin models. That's behind the Auto-DAN solution and in most of the IES projects, because, well, I think digital twins have the different concepts across the industry. I think when we talk about digital twins, like, it can be purely data-driven, it can be, in our case, a combination of both. We have, that's why I thought it was important to remark what a digital twin is in Auto-DAN, that is a combination of the physics-based engine and the IoT sensors data. So we combine both, we fill in the gaps, we improve accuracy, and enable this data prediction. And that's what we call digital twin at the end of the day. I thought it was important because I think sometimes we all use like fancy words and we don't have the same understanding. So yeah, that's the reason we use them is for the predictive functionalities that they have. So we can simulate potential scenarios. We are in the virtual environment. There's no risk. You don't need to go on site. So we can create those models and provide predictive insights, which actually augments the decision making to the users. So finally, I hope I didn't speak too long. Try to compact all the information here. Finally, I just want to remark three things. So what Auto-DAN does in terms of augmented intelligence is enhance this decision making through this augmented intelligence, through real-time insights, automated data handling, and predictive capabilities. So the platform, and that's the second remark, empowers the decision maker. So it's not about replacing the humans, we are trying to augment it, we are trying to empower them. And finally, and just to highlight the UX process, the user is not only a customer in the solution, it's part of the development process, and they're co-designers of the solution.
After. Thank you, Beatriz. Yeah, you actually mentioned it exactly. So as we said, so in this project, the real controller is the person. Okay, so we are just empowering them, allowing them to make the best decision possible according to somehow to their information and the device that they have in their house. And now, how they can do their best decision? Through this life energy assessment framework. So there is this platform, this tool somehow that RINA is developing, that Arianna Verga is going to present now, that actually summarize properly all the main consumption informations and forecasts so that people can decide what is the best for them to reduce the energy bill. Arianna, the floor is yours.
In this speech, I will talk about the self-energy assessment framework, as Simone said, that is a key exploitable result of the Auto-DAN project. So what is it? This is a typical overview of an energy assessment framework, and it is mainly composed, as you can see from this slide, by three main elements. On the left, you can see the inputs, and these inputs characterize the physical behavior of the and also it influences its electrical and thermal energy. The inputs depends on the architecture of the building, its location and its orientation. And during the operational phase, there's no chance to change them or make something on them. The second element of this framework is represented by the bags. The bags equipped within the buildings represent a key rule in this framework because they allow us to know the behavior of a building. And they can adapt the functioning of the building according to the different input that you receive. So it is possible in this way to manage better the use of the energy. And lastly, the output of this analysis is represented by a report on the building that represent where the consumption, the energy that has been consumed, divided by different building services. As you can see from on the right, these are mainly the main services that is possible to highlight in this kind of framework, and they are a bit limited because they just represent some services present in the buildings. And also this is a kind of analysis that can be applied on large buildings and not on residential ones, for example. So this framework guarantees a complete assessment of the energy performance of the building. But what does Auto-DAN introduce in this kind of framework? So the step forward is represented by the introduction of the consumption of appliances in the output. And especially in the residential building, the appliances plays a very important role because if the users know the appliance that consume the most, they can try to act in order to reduce their consumption. So all of this information passing through a proper conversation factor can lead to the calculation of an overall energy performance index. This value can sometimes be difficult to understand by users that are not technical users, just an owner of a building. So what we have had in the Auto-DAN framework is the normalization of the consumption against different reference value, as you can see from here, according to literature values or historical values. And by doing this, it is possible to calculate the KPIs that are easier to understand in this way by the users. So they don't have to go in deep into numbers, but they can just visualize in this traffic light system that Auto-DAN has developed the result of the energy performance of their building. So as said, this is a very simple and effective representations of the result of the consumption that everyone can understand. The advantages of the Auto-DAN's framework is represented by the fact that this is an holistic assessment that considers not only the performance of the building as a whole, but also consider the appliances, the demand response, and the building automation level. And what's more, it provides simple feedback to the users. Both technical and not technical users can understand the feedback that he provides, and this increases the awareness on this topic. And these advantages can be translated into benefit also. As you can see from here, the users can have a real-time indication of the performance of the building. So they can personally act to improve the energy management system according to some strategies that are suggested. On the right, you have this scheme, and for example, in here, Auto-DAN suggests a loading shift. So it says that maybe it is better to make an appliance works in another time where there is a higher PV production. And lastly, another benefit is represented by the fact that Auto-DAN give also an home appliance replacement simulation. So it compares the current appliance with a better performing one, giving information about the cost saving, but also the energy saving. So that's all. Thank you.
Thank you, Arianna. So we have been talking a lot, I would say, about software, digital solution. Now we have the hardware, the real hardware. You can see here with your eyes. So I introduce with this Ciarán from mSemicon. He's the general manager of this company from Ireland, and in this project he is a technology provider.
Well, thanks for coming. Sit down or stand up. Sit down, maybe. I'm the general manager of mSemicon. We're based in Dublin, and we're a company where our business is to develop electronic controls for various things. A lot of it in energy and IoT devices. I'm joined here today by Colin Forster, our technical director, down the back there. So I press the button. Yeah, we've been involved on several different levels here in the Auto-DAN project. As Simone said, we are a hardware developer developing a hardware solution for it, but we're also, because a technology provider is the technical term, we're also a pilot site coordinator. You heard earlier that one of the sites is Greenough Business Park in Ireland, the one we're in, so it's a new role for us to coordinate that particular part of the project. But also we're a participant, so some of the equipment, not ours, but some of the company's equipments are actually in our own building, so we're actually a participant as well. So we have a rather broad experience in the project. Anyway, obviously, if you're dealing with energy management, a fundamental part is to actually measure the energy itself. So that's what we actually developed as part of this project, was a meter, simple. It's a power meter that measures electricity consumption and presented the data in the form required for the Auto-DAN project. You can see the most recent version of it here in that box over there. It's running at the moment. It's actually charging my laptop. So anyway, in the Auto-DAN project, the way it works is it measures and reports power every 2 seconds and every 15 minutes, because there are certain parts of the project that required both different types of data. The 2-second data was required for a demand management part of the project that hasn't been mentioned yet. It's easy to install. It reports by Wi-Fi, so quite easy. Colin, maybe you could show the latest version of that. We have a QR code. Waiting for it to power up. Okay, with a QR code way of hooking it up, so it's quite easy. It's integrated also into Society, that was mentioned already, so all the data gets aggregated there on Society, and then it's distributed to the various partners. And also, an interesting thing, we all focus a lot on electrical consumption, but many houses, especially in Ireland and in Spain, use other forms of energy for heating, and that's a big part of energy consumption. In fact, probably most in most cases. So we came up with a method where we extended the functionality of the meter to collect the status of a gas boiler monitor. We just developed a very simple device here. You just put it on the gas boiler, and it measured vibration essentially to tell us if the gas boiler was on or not. Anyway, this device is being used in Spain and in Ireland at the moment. That's how the extension works. This uses down the left there is the gas boiler, and there's a little meter on little devices on it. It senses the status. It reports to our meter. It consolidates the data in our meter, and all gets reported together through Wi-Fi back to the society. So you know, it's a relatively simple implementation. It saves you having to have a whole parallel system that you need to integrate separately, just for measuring that particular status. The technology used is called LoRa-Fi. It's radio communication. It's local, but relatively distant as well. You can get up to maybe 100 meters very easily. Yeah, so next slide. So, yeah, just put in our experiences here. It's not just hardware development. We were also participating in the implementation here. We learned a few things ourselves about the way these kind of trials work. You know, reporting frequency. Not everybody wants the same frequency. Not everybody wants 15 minutes. Somebody wants 2 seconds. Somebody wants 15 seconds, and so on. So we just bore that in mind in our development. Another thing, I mean, it might sound silly, but sometimes it's hard to track where these pieces of hardware are actually placed. You know, a project might last months, years, and there might be a participant who's left the project, for example, and you move the hardware to somewhere else, and somebody forgets to maybe record exactly where it's gone, or just silly things. So just an observation. Another bit of data that's quite often difficult to get is historical power data. You're trying to compare. You're trying to measure how much better our solution is, our augmented solution, than previous solutions. But how do you compare it to that? You ask for the history of the invoices, of the bills, and if you're lucky, you'll get them, you know, but you don't always get them. So we just bore that in mind as well. We have a way to get around that. Yeah, another thing, in some cases, a lot of people have solar panels now, or they're car charging, or there's other things that are significant that you might want to measure as well, without having a second meter. Solar panels are typical in that case. I guess I mentioned earlier the issue of gas and heating oil. You know, you want to report them, and they generally tend to be old technology in most houses, so you don't have all these smart systems in those devices usually. Anyway, another observation is that again, as someone who had to visit these places, in this case businesses, you know, I and my colleagues have had to go and visit these places multiple times for various reasons, and you know, we're all very polite, everybody's nice, but it's just something you want to avoid, you know, if you really, especially if it's, you know, 10 times, you know, so it's just, again, you know, you want to reduce that kind of event. So anyway, there's just their inputs in the continued development of this product. Anyway, as it stands right now, this is more advanced than what we've installed, but this is where we are at the moment. This is our latest version of this same bit of hardware. It's configurable in the sense that you can report from 1 second up to 15 minutes as you wish. You can do that remotely as well. It's compact and low cost, easy to install. It has 2 current measurements on the same phase, okay? So that's handy for, you know, two different loads that you might want to be measuring. Its data is secured. It's endpoint configurable. Again, that's another thing. We have our own platform that you can go on and see the data, but some people, and especially researchers, they want to be able to send the data to their platform, whether it be Sensity or iScan or somewhere else. It's very simple. You just send the correct IP address. Yeah. No, I'm actually on the web server here on my phone. Anybody on the same SP or LUX Wi-Fi can see what's on that just by putting in the right credentials there. So anyway, endpoint configurable, as it's an end-to-end solution. So we have our own platform if you want to use that. And also very important, we report separately import and export power. So sometimes you want to track those things separately. So they're reported separately for the two different loads. Yeah, we have Wi-Fi enabled. We're doing a GSM card for it as well, so we'll be able to report directly over GSM if you want to pay the cost of the transmission. And it will have the LoRaWi expansion, which means we can connect it to our gas boiler monitor. Be adding in the future. It has a thing called a virtual monitor. That's our platform. We'll talk about that in a moment. Again, we enjoyed very much, and we are enjoying very much being a participant in this research trial, and we're quite happy to consider other trials, other projects that require some sort of customization for this device here. There's something you want that's a bit different from this. We're quite happy to entertain the idea. Anyway, it meets all the regulations and things. Installation. Now, this is where I talk about the virtual monitor a bit. I have it here. Anyway, as a part of the feedback, part of the experience was, you don't want to be going in and meeting the house owners all the time. Yeah, you get very friendly, you get a cup of coffee, whatever, but it's just, we want to avoid doing too much of that. We use this Pana Monitor, which is our platform, our app for the installation. And one of the things we can do is we can create these, what we call virtual monitors. Let's say you have a load of participants, maybe 20, 30, 50 participants in a trial, but you haven't got to the stage of installing your devices yet. Well, you can create virtual monitors for those locations and start putting data in that's relevant to that particular participant, including consumption. So the user, for example, can put in their kilowatt hours on their standard meter, and that's recorded with the date, and so you have it there. So when you put in your real meter, you just integrate the two data together. So you have your history right before the project starts. So again, you avoid looking for the bills, for example, which I don't know about you guys, but I found it extremely difficult to get the bills from the businesses who have bills. You know, they have their accounts, but with different suppliers, with online billing and so on, they just some people just don't have it. A lot of people of the 15 businesses, we got proper bills from one of them. You know, the rest of them were just not quite. It was not extremely difficult to get, and you need it. I mean, if you're comparing, you know, we have a history of the data anyway, so we have it. One way to do this is to use this virtual monitor concept. Another thing, a label can be assigned. So once you install it, you say the label is number 5, you know, kind of road, whatever. That's recorded in the same data stream. So even if somebody doesn't write it down on some notebook, you still have the information there in the data stream. All this is to reduce the number of times you have to go back. So these are data that our colleagues in RINA provided. Again, it's from our meter that went to typical energy consumption it's a typical week. Problem is different glasses for different lenses. Typical week for winter, that's the one of them. The autumn, another one, or the spring, and the other one is the summer. So you can see the consumption patterns changing. That's data every 15 minutes. We don't have the 2 seconds data there. That's used for different purposes. Get from any meter, I suppose. It's just reliable data coming in from one of the houses in I think it's a cool. Summarize here. We believe this device here is a very versatile power meter. You can do a lot. We can change, we can update it, we can put other functions in if required. It measures all the usual things: power factor, volts, amps, kilowatt hours. constantly developing it with new features all the time. Many of them a result of our experiences in this particular project. It's configurable in as much as we can make it configurable, such as the endpoint, such as the frequency. And it will be ideal for other research projects. So if any of you have anything in mind, we'd be quite happy to hear from you. So that's my bit. Thank you very much.
Thanks, Kura. So now we will try to revitalize a bit this session. So please stop working, close your laptop. We will do now a short survey just to understand what you understood up to now. I'm joking. So please scan this code. So I'm going to read some sentences, and yeah, this is just a survey that for us is really important, because we would like to understand what is your perception about this solution. So as you understood, the Auto-DAN solution looks more like a very advanced home assistant that you should pay for it. And this solution somehow allow you to do better decisions, to optimize your building operation. But since now we are going to enter the last year of the project, we are actually going also to assess the economic value. So some of you already started answering, but I don't. We see also the answer. So we have just 3 questions. So the first one is that which of those solutions you are going to prioritize to reduce your energy bill? So you can just installing a PV plant to reduce the electricity you buy from the grid, or you can install a solution like a building management system like the Auto-DAN one that improve the operational use of the building, but also increase the comfort level in your house. And the last one, if you somehow would invest in a deep retrofit, so huge investment where you somehow totally upgrade your home. So this, however, will require a very high investment. So for us, it would be interesting to understand, if you have those options, which one you would be willing to choose. And as you can see, it looks that the majority of us may invest less money, but having a good fitting solution, a good digital solution like the Auto-DAN one. But let's move forward with the question number 2. Now, if you are going to buy this solution, so the digital solution called Auto-DAN, which business somehow, which somehow option will be more suitable for you to pay for it? So would you be happy to have like a long operative renting contract where you actually pay a monthly fee, and after, I don't know, 5 years, you own both the hardware and the software solution? Or you probably, for the second option, you would prefer just to pay a monthly fee for the software, that if for 1 year you don't want it anymore, you don't pay it, so like, I don't know, Netflix, but you have to buy the hardware that is needed for keep it running? Or the last option, where you buy everything, one shot, so you pay the entire infrastructure, but you can also benefit from discounts, incentives, and you don't deal with any somehow energy service company or any somehow subscription fee. And here there is not yet a full answer, but it seems that the majority of you would prefer the software as a service solution. Let's move again to the last question. Now we are going to speak about money. So as you understood, the Auto-DAN solution is a home assistant that suggests you how to make your best decision. But there is no guarantee that you achieve the exact amount of savings. So only if you improve your behavior, if you are a good client, a good customer, a good citizen, you are able to achieve the expected savings. But nobody will provide you a guarantee for that. Nobody will reimburse you if you don't meet those goals. So with this question, we would like to understand how much a citizen would be willing to pay. And there, in between these 4 options, there are somehow different ranges. So with the first answers, we try to understand if you want just to, if you pay between 10 or 30 euros or between 30 and 50 euros without any guarantee of the savings. So you pay just to have this home assistant that provides you suggestion. And then there are the last 2 options where you say, okay, I will be happy to pay a bit more, but if someone provided the same amount of the same amount of cost from this solution, provide me the same amount of savings in the bills so that I can compensate somehow my expenses. Or you will be happy to pay somehow between 50 and 70 euros per month, but only if you actually save more energies, more money with respect to the monthly fee that you are going to pay. And according to those results, it seems that you want to pay too much. So the majority of you will be happy to have this light solution that provides suggestion, even if there is no guarantee on the consumption. Thank you very much. Those information will be really helpful for our studies and for our business modeling analysis that are going to start soon. Now we close the session on Auto-DAN and we just have the last presentation of the SATO project. So I invite here someone has any question in the meantime, feel free to ask.
I didn't mean to jump. You may want to ask that last question to normal people, so people who do not come to an event called Sustainable Places, because if you go on the street and you tell people, I want you to save energy, but then somehow at the end of the month you pay more, and I don't know how that sells, that message sells. And if you are planning to make that mandatory, you are getting even more people with pitchforks protesting outside the EU Parliament, I'm afraid. So check that with normal people.
Okay, thanks for the comments. Now we're going to close the session with the SATO project. So I invite here Professor Pedro Ferreira from the University of Lisbon and Pablo Gilabert from CYPE. So we have the last summer session on the SATO project that has been presented several times at this conference. But yeah, it's a sister project of Auto-DAN, and there are a lot of somehow interesting things to be shared. The floor is yours.
Thank you very much. I'm here with my colleagues Vinicius, Manuel Fonseca is also there, and Pablo, which will be also presenting part of the work. So the SATO project actually is a sister project of Auto-DAN because it was financed in the same call and trying to answer the same challenge that the call was raising. SATO stands for Self-Assessment Towards Optimization of Building Energy. That's a short name in our case for the project, but with kind of the same objective, sorry. So what I will try to do now is, as fast as I can, try to give you a bird's eye overview of the project, what we did in that project, but without going into too much detail, otherwise we'll spend too much time there. So let's go directly to the challenge that we were addressing. Of course, there is, as it was already noticed here, there is a clear gap between design energy performance of buildings and the actual performance of the buildings when we are using them. That we can measure with devices as we've seen here before, and we can then evaluate or compare the measured performance with the design performance or historical performance that we already might have. And to bridge this gap, the problem that we've seen also stated by the Auto-DAN members is that most actors, stakeholders, owners, the building managers, occupants, they don't have the necessary information and the analysis or the assessments that allow them to conclude whether their building and their utilization of the building is above or below average, or they should spend less or more. What they can do. They don't have enough information in general. And that is the general challenge that this call was raising. Try to respond with the objective of creating a platform where we could do automated self-assessment and optimization of buildings. IT platform that we'll go over in the next slides, trying to picture the workflow of it, how it fulfills this objective. The idea that this platform should be capable of assessing the real-life energy use and the performance of equipment. So our approach was heavily supported and grounded on the integration of data and systems. The interoperability problem. But we wanted to use this kind of approach based on semantic models, descriptions of the devices, the systems, the building itself, the zones, the assessment zones, even the processes, the assessments, the computational processes that we implemented to make the assessments that will provide the information to the users. We wanted to do this in a way that could be scaled or automated for large buildings and applied in general. This was actually the reason to go with that kind of. So let me try to show you what is the idea behind the platform and how it could be instantiated on a new building using also the technology of BIM models and BIM files. So the idea is that by having a specially crafted BIM file that has additional layers specifying where some systems, some sensors, defining the zones, the assessment zones that we want to analyze on the building. If there is such a well-crafted and complete BIM file, this file will be ingested by the platform, and this will bring enough information to start populating what we call a context information model in our middleware that will then allow us to determine for different zones, different rooms in the building, because there is a sensor, because there is an HVAC system, because there are different systems, we can already decide, okay, I can do this assessment, this service to manage a certain aspect of the energy consumption in this building, and deploy all the computational processes that implement these. So we have operational interfaces and BIM files to set up the system with the descriptions, as I told you already. In a second stage, by using that information, we have this context information model. We provide the IoT interoperability, the data integration, so that then data from together for a given purpose. We have those semantic descriptions to try to automate as much as possible the operation of all the processes. And at this point, the platform becomes ready to receive the data from the building, because it already knows from the IDs of the devices which values belong to each sensor, to each room, to each zone, and then how to use this data to that we have. Probably not surprisingly, we also have a layer on our platform which is called self-assessment framework, because actually the call was calling for such a thing. This is where we, based on what we have in the layer below the SATO middleware, this is where we implement KPIs and assessments. So KPIs are indicators of the performance of different aspects in the building or different equipment. The assessments are already more judgmental, so they compare these KPIs either with historic data or regulations or design performance that is expected, and then provides an assessment of what is going on in the building, analyzable data in the building. Finally, not finally yet, but almost finally, another layer on top of this self-assessment framework, we have a set of take this information as inputs, so the results from the assessment, try to either automatically by controlling systems in the building or by suggesting actions to the user, so as an advisory service behavior, they try to improve the efficiency of different aspects that have an impact on energy consumption. This is part where the user is already involved in those energy management systems that are not fully automatic. Now, yes, finally, the last layer that we have is the interaction layer with the users. Manuel Fonseca will tell you something more. No, it's only Pablo today here, yes. But there was also some design procedures to obtain the interfaces that we have. We have three kinds of interfaces. We experimented with different approaches. We have BIM-based interfaces with 3D models where we try to project the results of the assessments using colors and different approaches, so that immediately the user sees, okay, regarding this assessment, I'm on red or on green, so you have a quick idea of what is going on. We have web-based, of course, and mobile applications that can also be used to visualize the results of all the assessing that is there in the building. In a nutshell, again, we had a mixture of residential and office type buildings. We have the library of the Faculty of Sciences. We have a university building from the University of Aalborg, which was a partner in our project. Quality office building in near Lisbon. And then for the residential pilots, we had also in Seixal, in the south of the Tagus River in Lisbon, a number of houses. It was around 30 houses that we also monitored, some with more success than others. A residential pilot in, I cannot pronounce it. Very difficult. That was connected also with the University of Aalborg, and we integrated with them. Finally, for the residential type of pilot, we had also in Italy some apartments in an apartment block that are connected to Politecnico di Milano, which was also a partner. Finally, we have two appliance and consumer electronic retail stores in Lisbon, which we use to compare different actions and to see the impact, to analyze the impact on the performance of the building. So all these pilots were tested and connected to the platform, and here in the middle you can see on the top the 5 categories of assessments that then are made on the different aspects of the building. Whole building energy assessment, assessments that are related to the envelope of the building, the efficiency of the envelope, related to occupants like comfort, the number of occupants that are inside the building, some specific building systems, like air handling units, HVAC systems, they are subject to specific assessments on their own performance. And then also appliances for the residential pilot. This was something, actually, when we were doing the grant agreement stage, the officer wanted us to look at appliances and try to bring a definition of what could be the real-life assessment that would go beyond the energy labels that we have. Below, on the same area, you have also the different categories of energy management services that we developed. Some of these pilots, not everything is tested everywhere, so we have a kind of pilots, but we have aggregated control and automatic control for some parts of the buildings, user comfort control. We have energy services that target the flexibility potential. Then also those that are specific for. So what are the main key exploitable results? I'll just enumerate them. This self-assessment framework has top of different systems other than our IoT middleware, so we could reuse it elsewhere. What we call the SATO consultant, which is the energy management services that are built on top of that information. SATO appliance utilization efficiency mobile app that was used for the pilot owners to be able to look at what is the real life efficiency of my utilization of the appliance. The service that I want. Then the Open Beam SATO, which is our interface approach using the Beam
CYPE or
CYPE,
whatever.
it's a software company.
Well, hello everyone. Simone told me we are running out of time, so I will be quick. Yeah, so let me. Well, I will skip this analysis. As you can imagine, most of these systems currently work based on a list of rooms, spaces, so you get some basic results. Then there are some others moving to representing this data in 2D. So you can have an overview of, okay, I have this problem in that place or this other place. And the idea here is moving to the 3D. So with just looking to the whole building, you can have, or you can obtain a simple approach of what is happening in every single part of the building. And for that, we are going to work with BIM. So we are trying to move from BIM to digital twin, including extra data, as you should know. And then we wanted to create a new layer working with augmented reality, so representing all this information from mobile phones in real places. Well, all of this has been included in this tool we have developed in this project, OpenBIM SATO. And I think the best way to understand how it works is with a video. I think it's the first time we show you a nutshell, but let me check if it works. Yeah, okay, so in this tool we can import IFC models, then we can locate the specific sensors of our buildings. We have built a layer in order to help us to control if we have located these sensors in the right place. We can apply some specific rules to control if the height has been well defined, if they are quite far away from HVAC installations. Then we have this possibility of representing all these results of temperature, CO2 in a 3D model. We can control also the contour plots in order to specify, okay, I want to control this margin and highlight problems in some specific rooms. And something similar with the assessments. You know, all this analysis that the platform has done represented here. In this case, we are showing the air quality, but we have the possibility of showing the occupancy, but also the thermal comfort. And this is the idea. So once we have everything, we can upload it to the cloud, and then from a mobile phone with a free tool, we can display this data directly in your desktop or in real scale in order to visualize, okay, the results of these sensors and assessments in the real place. Okay. So I think this is a general idea. You got, I'm sure, some points. Here I just want to explain the workflow. So this OpenBIM SATO has two main sources of data. One is coming from the SATO platform, all the data, the real data. And then the other one is coming from BIM Server Center, which is a platform specialized in BIM. And we are merging all this information in our solution. If we modify the BIM model or we modify the data, the real data changes, of course we update this information in real time. Then we have identified, focus on exploitation, two main phases where we can apply this tool. On the first stage, we are using this tool in order to help designers like architects or engineers to define this IoT infrastructure. I think it's becoming quite important. I'm an architect, and as currently we need to think about the best solution for lighting, for plumbing, or whatever. It's important having in our mind a good solution for the IoT. So as I was saying before, which is the right height to locate the specific sensors of temperature, CO2, or the right place to avoid obtaining wrong data, no? Like locating the sensors far away from the HVAC installations. And then on the second phase, we have the solution which is going to bring all the data coming from all this real information, so we can analyze how is the real performance of the building. And I think that's all. To finalize, we can represent all this information in augmented reality or virtual reality in order to have another experience. So I think that should be a summary. Thank you very much.
Thank you very much. Thank you to the SATO consortium for those achievements. Really impressive, I would say. So we can actually close the session here, but if you have any further question, we are available for you. So I don't know if there is any question from the audience. No? I know that majority of you are tired, so thank you again for being with us this afternoon. I look forward to having you at the gala dinner later, so, and see each other even tomorrow. Thanks again, and have a great day. Bye.